Hi everyone, I'm going to show you guys how to integrate 1 over 1 plus x to the power 4. So you could write 1 over 1 plus x to the power 4 as 1 minus x squared over 1 plus x to the power 4 plus 1 plus x squared over 1 plus x to the power 4, right? But there's one more thing you should add into this. You should multiply the whole thing by half. Because you'll see if you add these two together, you'll have 2 over 1 plus x to the power 4, right? And to make it equal with 1 over 1 plus x to the power 4, you have to multiply this by half. So that's why I'm multiplying by. Ignore the half for now. Let's just focus on integrating 1 minus x squared over 1 plus x to the power 4 dot dx plus 1 plus x squared over 1 plus x to the power 4 dot dx, right? So now what I'm going to do is I'm going to divide both the numerator and denominator by x squared. So I'm going to write 1 over x squared minus 1 over x squared plus x squared dx. And I'm going to write 1 over x squared plus 1 over x squared plus x squared dot dx. Okay. And now, so we have the denominators of 1 over x squared plus x squared, right? Let's try to make them completing squares. So let's focus on this. So what if I expand 1 over x plus x in brackets squared? That gives me 1 over x squared plus 2 plus x squared, right? Which is not equal to the denominator. So how do you make it equal to the denominator? All you have to do is just subtract by 2, right? So then you can write 1 over x squared plus x squared equals to 1 over x plus x squared minus 2, right? So I'm going to use this as the denominator for this fraction, and I'm going to use a different completing square format for this denominator. So I'm going to write 1 over x minus x. Let's see what we get when we expand that. So we get 1 over x squared minus 2 plus x squared, right? So how do you make it equal to the denominator we have? You just add 2, right? Yeah, that's all. So now you could rewrite this as 1 over x squared minus 1 over 1 over x plus x in brackets squared minus 2 dot dx plus the integration of 1 over x squared plus 1 over x minus x squared plus 2 dot dx. You'll see why I took two different denominators for the fractions. It's because when you take substitutions, you need to cancel off the numerators, right? You'll understand why I took it like that. But anyways, if you guys have any doubts, please drop a comment. I'll help you guys out. And now, let's focus on the fraction we have on the left side. So I'm going to take a substitution of u equals 1 over x plus x. So du over dx is minus 1 over x squared plus 1, right? If you factorize minus 1 out, meaning you take minus 1 out, it would give you 1 over x squared minus 1, right? So du over dx equals to that. You could write du over minus 1 over x squared minus 1 equals to dx. Now let's go back into our question. So we have 1 over x squared minus 1 over, instead of 1 over x plus x, I'm going to write u squared minus 2 dot dx. Instead of dx, I'm going to write du over minus 1 into 1 over x squared minus 1. So you can see the numerator cancels off with this, right? So you could take the -1 out. And now what you have to integrate is 1 over u squared minus 2 dot du. So now you have to use partial fractions to integrate 1 over u squared minus 2. So 1 over u squared minus 2 I could write as 1 over u plus root 2 into u minus root 2. Right? And this I could write as a over u plus root 2 plus b over u minus root 2. So now let's multiply all the terms by u plus root 2 into u minus root 2. So you have 1 equals to a into u minus root 2 plus b into u plus root 2. So then you can write when u equals root 2, 1 equals, so you'll have 0a plus 2 root 2 b, right? So b equals 1 over 2 root 2. And when u equals negative root 2, you'll have 1 equals to minus 2 root 2a plus 0b, right? So you have a equals to negative 1 over 2 root 3. So meaning you could write 1 over u squared minus 2 as 1 over 2 root 2 into u minus root 2 minus 1 over 2 root 2 into u plus root 2, right? I must admit I made any mistakes. Yep, everything looks good, yeah. But don't forget we had a minus in front, right? So when you go back into your question, you have to put your minus, and now you have to integrate 1 over 2 root 2 minus root 2 minus 1 over 2 root 2 u plus root 2 dot dx. So du. Yep. Okay. So what would the integration of this be? Easy, right? It would just be 1 over 2 root 2 ln u minus root 2. You don't even have to do that. You could just straight away write the answer because it's that easy. But if you guys have any doubts, just let me show it to you guys. I'm just going to differentiate this. So how do you differentiate that? You'll have 1 over u minus root 2 into the differentiation of what you have inside the ln function. So the differentiation of u minus root 2 is 1, but you have to finally multiply it with 1 over 2 root 2, right? So you can see you get the same exact thing. So that's that. So what's the integration of this? That would be minus 1 over 2 root 2 ln u plus root 2, right? But we had a minus in front. So your answer would be 1 over 2 root 2 ln u plus root 2 minus 1 over 2 root 2 ln u minus root 2. And you can bring these together using logarithmic rules. As you can see, the negative, if you factorize 1 over 2 root 2 first, and then you have this and this together, right? When you have negative, you know that the terms you have inside should get divided. So this would be your answer. And this is the answer for that integration, for the one we had on the left side. For this, right? Now we need to integrate this. So let's write that down. I'll use another color. So the integration of 1 over x squared plus x squared over 1 over x minus x squared plus 2 dx. Let me just recheck that. Yep. So I'm going to take a substitution of u equals 1 minus x. Sorry, 1 over x minus x So du over dx equals to minus 1 over x squared minus 1. So I'm going to factorize that, and I could take minus 1 out, and I could write 1 over x squared plus 1, right? Oh, I'm sorry, I think I wrote the numerator wrong. This should be 1. Let me check again. Yeah, it's 1, sorry. I wrote x squared. Sorry about that. Yeah. So now we can write du over negative 1 into 1 over x squared plus 1 equals to dx. You go back to your question. So you have 1 over x squared plus 1 over, instead of 1 over x minus x, I'm going to put, one more thing. Now the previous substitution we took as u, right? I'll take this substitution as u dash, or else it would be confusing. So it's u dash, alright? Yeah, u dash. So instead of 1 over x minus x, I'm going to write u dash squared plus 2 dot. Instead of dx, I'm going to write du dash over negative 1 into 1 over x squared plus 1. You can see the numerator cancels off with this, right? You take minus 1 out, and you need to integrate 1 over u dash squared plus 2 dot du dash. So how do you integrate this? So what I'm going to do first is I'm going to take 2 out from the denominator. So meaning, I take half out, and you have 1 over u squared over 2 plus 1, right? Du dash. So I forgot to mention dash. And I could rewrite this as u dash over root 2 in brackets squared, right? Now I'm going to take a substitution of t equals u dash over root 2. We can write dt over du dash equals to 1 over root 2. Root 2 into dt equals to du dash. So we had minus half into 1 over, instead of u dash over root 2, I'm going to write t squared plus 1 dot root 2 into dt. So we have negative root 2 over 2 outside, and we need to integrate 1 over t squared plus 1 dot dt. So how do you integrate 1 over t squared plus 1? This is easy. You can directly write the answer, but if you guys want me to show it, please drop a comment. So the integration for that would be tan inverse t. Inverse t into root 2 over 2, negative root 2 over 2. So it's negative root 2 over 2 tan inverse, and instead of t, I'm going to write u dash over root 2. So now we found both the integrations, right? So now we could bring our answers together. So we have root 2 over 2 tan inverse u dash over root 2 plus 1 over 2 root 2 ln u plus root 2 over u minus root 2, which was our previous answer for the other fraction, right? Plus c. Now let's put in our substitution. So we had u dash equals 1 over x minus x. So you could rewrite that as 1 minus x squared over x, right? So when you put that in, it's root 2 over 2 tan inverse 1 minus x squared over root 2 x, right? Okay, and for the one you have on the right, which is our ln function, we had u equals to 1 over x plus x as our substitution, right? Okay, so you could write u equals to 1 plus x squared over x, right? And when you put that in, let me go on to the next page. So we have 1 over ln u plus 2 over u minus root. So just focus on what you have inside the brackets. So u plus root 2 over u minus root 2. So when you put the substitution back in, it's 1 over x squared over x plus root 2 over 1 plus x squared over x minus root 2, right? You could write this as 1 over x squared plus root 2x over x over 1 plus x squared negative root 2x over x. You cancel off the x's out, and you can write it as 1 over, you can write it as x squared plus root 2x plus 1 over x squared minus root 2x plus 1, right? Now let's write our final answer. This is going to be the final answer, the one I'm going to write now. So negative root 2 over 2 tan inverse 1 minus x squared over root 2x plus ln x squared plus root 2x plus 1 over x squared minus root 2x plus 1 plus c, but there's one more thing. Oh, hold on a minute. I think I forgot to write the constant in front of ln. So tan inverse, put it again, 1 minus x squared over root 2x plus 1 over, but there's one more thing. Remember we took half outside from the two fractions we wrote, and I told you guys to just leave it aside for now. If I go up, you can see I didn't take this half into our integration, so I just left it aside. So I have to put that back in, right? So all I have to do is just multiply these two by half. So it's negative root 2 over 4 tan inverse 1 minus x squared over root 2x plus 1 over 4 root 2 ln x squared plus root 2x plus 1 over x squared minus root 2x plus 1 plus c. This is your final answer. So if you guys have any doubts with this question, please drop a comment. I'll help you guys out. And this is everything for this question. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.